All right, what we're doing today is we're wrapping up chapter 8 and we're looking at proportionality theorems that exist in triangles and other shapes. The first one we have is the triangle one, okay? And what this says is that if you have a line that's parallel through the triangle to one of the sides, then it cuts the sides proportionally. So the left side will be cut proportionally to the right side. It also says that it cuts it into two proportional triangles. So I have the smaller one, which is ABD, and then I have the bigger one, which is ACE. And so those are also proportional. So there's a couple different ways that you could see this. It could either be the sides or it could be the whole triangle, okay? And so we have two examples of what this looks like. So here, if you notice, I'm given information on the sides. And so what we know is that the sides are cut proportionally. Okay, so 8. Actually, I'm going to put the x on top because I don't want to have to flip my fraction. So it's going to be x over 8. And then that's the left side. What's in the same position on the right side? 3 over 12. You also could have set it left over right, so I could have done x over 3 and gone back to the left and did 8 over 12. All that really matters is that your x is diagonal from your 12. So there's a lot of different ways to set it up, but you just have to make sure that you either do left over left, right over right, or left, right, left, right. You have to be consistent. And so now if I were to solve this, I would times by 8, and that would cross the 8 off. And so 3 times 8 is 24 over 12, which is 2. Okay? So the easier ones are when you're given information on the left and the right. On this one, if you notice, I'm given these bottoms. And so when you're given these bottoms, you have to think of the bottoms of the triangles, and they're separate. And so what I have is, I'm going to erase that right here. Let's see, there we go. So what I have is I have two triangles. I have the left and the bottom of the small triangle. And so let's write that. The left over the bottom of the small triangle. So left over bottom. Now I need to do the same thing for the big triangle. But here's the thing. The big triangle is this whole thing. There's the whole left. And here's the whole bottom. And so the entire left is these two together. So 2 plus 6 is 8 over the bottom x. And so now I'm going to flip them, and I get 5 over 6 is equal to x over 8 times by 8 on both sides. And so I get 40 over 6 is x. And if you want to write it as a decimal, you can. And so it's 6.67. So either of those two answers will work, but hopefully you see the difference. The key here is if you have the parallel lines, you have to look at it as the small triangle and then the big triangle and write similarity statements between those. Not similarity statements, but ratios using those. Okay, the next thing we have is angle bisectors, and this one's actually pretty easy. We're going to say that BD bisects that angle. And so what that means, remember, is bisecting is you're cut in half, so this angle is equal to this angle. So if that situation arises, then what happens is this left side of the triangle is proportional to this right side of the triangle. Okay? So we get a couple examples to show that. So here's x is on the left, so I'm going to put that on the left. So x over on the left side, the other left side. And then what's in the same position as x? That's right, 5. So 5 over 10. You also could have set it up x over 5, so top triangle over bottom one, and then you'd have to go back to that and do 8 over 10. There's a couple different ways to set that up, but you just have to make sure that they're in the same location. So I'm going to solve this one. I'm going to divide by 8. I'm going to get rid of the divide by 8 by multiplying by 8. And so I get x is 40 over 10. So I get x is 4. Okay, so let's set up this one, or why don't you guys try setting up this one? And when you think you have it, press play so you can check your work. Okay, so here's x. So x, I'm going to do this one to the other side. This, what's in the same position as x is 8. And then I have to go back to the side, or to the side of the triangle that had x. So that was that one. So the only other number there is 2, which is in the same place as 5. If you set it up the other way, you probably did x over 2, which x is in the same place as 9. So 9 over 5. Doesn't matter which way you do it. You're going to get the same answer as long as you do your math right. And so I get 18 over 5. And 18 divided by 5 is 3.6. So this one's a lot easier because there's none of those whole triangles. It's this one, this whole triangle one right here, that's going to get people mixed up. So be careful with that. All right, one last type, and this is lines of proportionality. So if lines are parallel, so if I have 3 or more parallel lines, the transversals cut them proportionally. So we'll change colors. This is in the same place as this. And then this one is in the same place as this one. And then the one that you have to be careful of is this tall, the whole thing. Okay, so I'm going to write my fractions. So I could have LM is in the same place as OP. MN is in the same place as PQ. And then LN is in the same place as OQ. See, all of those things work. Okay, so you kind of have to pick and choose what you're going to do. Right here, I always like to start with x. So x is on top. And x is in the same place as 8. And then my only other number I have over here with x is 20, which is in the same place as this whole thing. And that whole distance is 15. Some people like to set it up where you do all over the right side and all over the left side. So if you did it this way, it would be x over 20. So I did right over right, but now I have to do what's in the same position. What's in the same position as x is 8. And the same position as this 20 is 15. So either of these fractions or these proportions, ooh, what did I do? No, there we go. Why are you going away, 20? Any of these proportions work. You could set it up either way, you just have to decide what works better for you or what you prefer. So to get rid of a divide by 8, I times by 8, and so I get 160 over 15. You can leave it like that, or you can divide it out, and that's 10.67. Okay, so you have different rules to see. A lot of them are set up the same. Left, left, right, right, or left over right, left over right. The trickiest one, again, is this one right here. When you have these parallel sides, you have to think of it as a whole triangle. But otherwise, you should be able to do this. It's not that bad. Just set it up and take your time, and you'll be fine.